So, starting over. So, thanks a lot, everyone, for coming. My name is Rotem. I'm the CTO and co-founder of Ariga. I've been here for the past few days with our team here in Saigon, in Ho Chi Minh City. We have a team of software engineers and here working with us on the product, on the open source project. We're also hiring, so if you're interested in working on some cool infrastructure, open source software, talk to us. As part of my job, I have the privilege to be a maintainer of two very large open source projects. The first is called Ent. Ent is an entity framework for Golang if you're building backend applications in Go and you don't love some of the existing ORM solutions. So take a look at Ent. Ent was started by my co-founder when he worked at Facebook. And today it's part of the Linux Foundation and really grew into something very big. The second project that I am maintaining and will be the topic of our talk today is Atlas. And Atlas is a database schema management tool. It's a command line. It's a cloud product. It's a Kubernetes operator and the Terraform provider. It tries to be a modern DevOps solution for how to manage your database schema. But by the end of the talk, I hope I have a pretty ambitious goal today, is to convince you that you should completely change the way that you manage database schemas. Now, if you are like any other software engineer that I know, it's going to be very difficult to convince you that you're doing it the wrong way. So bear with me and talk to me afterwards to see if I change your mind in some way. So to begin the story, I want to tell you about my first production setup. And this is pretty long ago. The first Python application I deployed in production, there was no AWS. And I had a VPS, a virtual private server, so it wasn't a physical, we already had virtualization. It was basically a VM, and it had Red Hat Linux on it, and it had a supervisor D running a Python process, and Nginx doing reverse proxy to set up, to serve the static files, and the database was living on the same server. And I had no Kubernetes, I had no Terraform, I had Git, and the way I was deploying was I was doing Git pull from this machine to deploy the most recent. So to some of you, I maybe look like a dinosaur. I come from a different era. Today, my company's stack, I tried to draw it. I was not able to fit it into one slide. So I thought, how can I represent the complexity of my infrastructure today? And you are all coming to a CNCF meetup, so you can appreciate maybe this slide, which lists the number of lines in the textual representation of the graph of the infrastructure. So I have 2,404 edges in the graph that represent my company's infrastructure. This is not very big. This is a 1.5-year-old project. It has a VPC. The VPC has security groups. The security groups have an EKS cluster. The cluster has nodes. These nodes have IAM roles, lots of stuff. And this is not even counting the amount of resources inside my Kubernetes cluster. But the point I'm trying to make is that modern infrastructure is very, very complex. This complexity, this rising complexity, has given birth to an old new paradigm and how to manage stuff. And this paradigm is inspired by something that is very relevant to Ho Chi Minh City, which is air conditioning units. I'll try to explain why. Managing resources is all about maintaining a desired state. I would really love this room to be 25 Celsius degrees. Wouldn't you all? An air conditioner is comprised of two very important components. One is the thermostat, that his role is to sense the environment and to know what the current temperature, and the controller, which is providing instruction to the engine, keep cooling or stop cooling. When you connect these two pieces, something very magical happens, and you create an autonomous feedback loop, where as the environment gets colder, the controller tells the engine to stop working or to work with lesser intensity. And as the temperature rises, the thermostat senses this change in environment and gives instructions. So you don't need a person to sit next to the AC and say, go faster, go slower. You have created an autonomous reconciliation loop that tries to maintain a certain state in the environment. As cloud infra engineers, we know these loops, they're a bit more complex, but the same idea holds. If we have auto-scaling groups that try to maintain a certain load, for example, 60% CPU, as long as load is higher, keep adding more servers. When load gets lower, you can start killing these servers. Okay, this is the same as our air conditioner. Circuit breakers. Doesn't matter if they are in process, service mesh, API gateway, they observe the error rate of the server, and when the error rate rises above a certain threshold, they start to shed traffic away. When the error rate decreases and time passes, they return to serving the traffic. And of course, one of the most magnificent, I'm not saying this cynically, I really believe it, one of the most magnificent pieces of software engineering in our modern era, which is Kubernetes, which is all about self-reconciling control loops. This approach to managing resources scales incredibly well. I have seen with my eyes clusters with thousands of nodes and tens of thousands of pods running and self-reconciling themselves to serve really critical production workloads. But there is a caveat, and that is that this approach starts to become a little bit problematic when you try to manage stateful resources, like a database. And this is what our talk today is about. To demonstrate this, let's consider how rollouts happen in Kubernetes. I'm assuming you're familiar with deployments in Kubernetes, so I will run through this without too much of an introduction. But when I change the desired state of a deployment object in Kubernetes, for example, I change the image tag, or I change the amount of CPU that the pod spec requires, or I change an environment variable to configure my application in a different way, Kubernetes will sense this and create a new replica set. This replica set is responsible for controlling a group of replicas, a group of pods that will adhere to the new configuration. Kubernetes starts to spin up new pods with this new pod spec. It waits for them to become healthy. When the pods are healthy and Kubernetes, the deployment controller is satisfied that the rollout is going on well, it will start to kill the old resources. In the end of the rollout, we are at our new desired state. This is a multi-step operation, but in the end of it, we are again in the stable desired state. My question to you is, what would happen if we had applied the same strategy to managing database schema changes? To summarize, you probably know that when your application code change, your data model change, you need to make changes to the database because the database needs to be compatible with the server. Otherwise, we make a query to the database, the new column does not exist, and we get an error. So part of upgrading applications in production is to make sure that the schema and the app are synchronized. This process is called database migrations, if you have heard about it in the past. So let's try to simulate the same approach that we did for a stateless resource like a pod if we do it for a stateful resource like a database. So we could spin up a new database with the new schema, check. Make sure it's healthy. A database with no production traffic is usually healthy. And then, once the new state is ready, we kill the old database. And our manager is crying. So, obviously, Kubernetes came to our industry. It was very, very exciting. And people, when a replatforming happens, I had the opportunity to watch a few of these happen in my short career, is people needed to figure out what are we going to do with our database migrations. How are we still need to evolve this database. We obviously can't treat it in the same way that we'd like our application. So people started to do all sorts of stuff, and most of that stuff, I guess you're doing it, was not a perfect fit for Kubernetes. But first, let's speak for a few minutes about what not to do, how not to manage your database schema in production. So the first thing, and trust me, I speak to lots of customers, lots of companies, and interview them about their development practices, how they manage production. You should not manage your database manually for a few reasons. It's error-prone. If humans are doing these changes, they might succeed in staging and everything will work, but then in production, typo, some other glitch, you might get an error, and it's not fun when it's your database. Also, you invest so much time in DevOps, CI/CD, automation, everything works flawlessly and without human intervention, but if you have this one step in your pipeline that requires humans to do it manually, even if it's a script that they run, this becomes the slowest link in the chain. You cannot deploy to production 200 times a day if you need a human to be there to press some button and observe its result. When it's humans doing the operation, they are not repeatable and not auditable. Sure, you can check in your migrations to source control, but unless the process is hermetically automated, you need another system of record to prove that what was documented to Git was what actually happened. And if you're a bank or if you're in a regulated industry, you need audits. You need to be able to prove that you know how your system changed. And the last is not fair. It is not fair to your employees that dedicate, your team members that dedicate their energy and their creativity to put them in this situation, this stressful situation that they need to manually upgrade a database. It really sucks. Second thing that we see a lot is that many applications run migrations when the application is booting up. When the server starts, I see some smiles here, is because you're doing it, and you run the migration as part of your main before your server is coming up. Now, if your application is running on a phone and it's an SQLite or something, sure, it makes sense. What are you going to do? If you have, one replica and you have a low scale, it doesn't really matter. It's a bit maybe not the most aesthetic solution, but sure, it's simple. But when you are managing a larger system, it becomes an issue for a few reasons. First of all, in terms of security. Your runtime environment should be as stripped down as possible. The role that you access your database in production should not have permissions to do DDL changes. No reason for it. It's a risk that you can avoid. The second thing is you don't want to bundle this tool, this Liquibase or Flyaway or whatever tool you use to run the migrations, to bundle it into your runtime environment, right? We have containers today, way to build containers that have like nothing in them. So why throw in another dependency to your runtime environment that's going to impose a security risk? Second thing is, if when your pod comes up, it needs to run something that can fail, and migrations do fail, what you end up with is a crash looping pod. A crash looping pod means a reduced capacity for your system. It's either a pod that you allocated resources to, and it's now taking up CPU and memory and doing nothing, and just crashing its way and stealing resources, Or depending on your deployment strategy, it might actually cause a reduced capacity in your production, right? Because you spin up and down in the same time, for example. Finally, migrations are a dangerous operation. They cannot run concurrently. You cannot have multiple pods coming up and trying to run the migration at the same time. You cannot create the same table at the same time because the second one will fail. It's not an idempotent operation. So this effectively means what migration tools do is they acquire a lock on the database. So only one Liquibase can upgrade your database at a time. What this means in practice is that if you have multiple pods trying to run migration at the same time as part of your deployment sequence, the first one is blocking the second and the third from coming up. So in general, it's considered an anti-pattern to run the migration as part of the application startup. What you should do, of course, you should automate. And automation means committing the changes to Git, using an automated, reproducible process that happens without manual intervention. Your system should be able to deal with failures, rollbacks. In short, you should give database upgrades the same respect as your application and infrastructure. You invest so much thought and creativity into these systems, give your database the same level of consideration. Now let's discuss a bit more about database migrations with Kubernetes. What are our options? Application startup. Bundle the migration tool with your pod and run it when it starts. We discussed this. Not a great idea. Kubernetes has init containers. We see this a lot. It's the recommendation on many nasty guides on the internet that are misleading everyone. It has some problems. We'll discuss them. You can use a Kubernetes job. Some guys are smiling. That's what you're using. Also kind of meh. We'll see why. Use Helm hooks or pre-sync hooks with Argo. Use sync waves in Argo. It's an improvement. Or you can use an operator for database upgrades, and this is what we're working on with Atlas, and I want to share with you today. So, init containers, they are better than bundling your migration with the application because it's a separate container, meaning the migration will finish, and then the server will start. And then your runtime environment at least will not have this extended attack surface. However, if your init containers fail, you're still in the crash loop problem. The server allocated the resources for your pod, and it's now contending with other things in your system. So you still have a crash looping, capacity reducing problem. Init containers are really nasty to debug. If you have a migration fail, and it happens in an init container, it will look like any other crash problem. It will not be immediately obvious that the problem was the migration phase. It will take you more time to drill down, look at the logs, figure out that the container that's failing is actually the init container and not the actual runtime environment. And finally, the failures are not immediately visible to your Kubernetes system. And I'll try to explain what that means in the next examples. Kubernetes jobs, this is a bit better because it decouples migration from application, meaning you can run one migration and only then move forward to migration. However, you still need a sync mechanism with the application. So you need to somehow manage the dependency between application and migration. Never start the application before your migration is done because your application need to be compatible with the database. Failures are still hard to debug. It's really annoying to have a million failed jobs and start to understand what went down and what really happened. And rollbacks with jobs don't really work. The reason is that the common strategy for doing a rollback is to take an older git hash, right, to take a previous version. Now, most migration systems, to roll down, they need to have the down migration file, the plans how to go from the future back to the past. But if you chose an image that is from the past, it does not contain those down migration files. So what happens in practice, if teams are rolling down a version that contains a database schema change, they usually need to handle this manually. So someone is going to connect to production, run the down migrations, or just ignore them. But it will really mess up the whole, thank you for smiling. It's helped me know that I'm on track. It's really hard to know what to do. And if the on-call engineer is not a database expert, this is an outage waiting to happen. Argo hooks, Helm hooks, a bit better because they give you a way to express the relationship between the job and the deployment, right? You can have phases in the deployment sequence. This is an improvement, and this is what I was using until a year or a year and a half ago that we built something new, but it's an okay solution. It's not bad, but we have some to improve because the rollback thing is still true, and it's still really annoying to debug, to have all these junk jobs lying around your cluster, trying to retry. Not a lot of fun. People are looking for a solution. It's not like people are content with this. This is recent screenshots from the Argo CD Slack channel. People are looking for the cloud-native way of how to do database migrations. And today, I want to tell you about Atlas. Atlas is our project. We open sourced it in 21. Immediately, it gained the nickname, the Terraform for databases. It's more than that, but I accept this as a humble compliment. It's widely used in the industry, small and large companies. Almost 3,000 projects on GitHub use it, and this is just public stuff. And Atlas lets you manage your database schema as code. So it tried to adopt the modern principles like GitOps and infra as code to the database management space. As part of this project, we not recently, I think it's almost a year ago, introduced the Atlas Kubernetes operator. And I will demo this in a few minutes, but the idea with the operator is you get a custom resource that represents your database schema, and you can modify this resource, and you have a controller in your cluster that is responsible for doing the up and down operations. It supports two flavors. One is version migration, which is similar to what you maybe know, that you have a file per migration. Each change, you write it in advance, and you can go up and down and all this stuff. And the second one, which is more modern, and is what I'm going to demo to you because I believe it is the future, is a declarative approach, where we provide the controller with the desired state of our database. The controller noticed this diff that we add a column, and it is now calculate on its own the migration plan to go to the next version, to reconcile between the desired and the current state. If you are freaking out about an operator planning changes to your database, you have a brain, it's scary, but we build lots of safety mechanism and policy that you can define to prevent the operator from doing stuff that you would not like to happen in your system, like dropping columns or deleting data. You know Victor? He's a YouTube star. If you don't follow him, subscribe to him on YouTube. It's really great. And he recently did a DevOps Toolkit episode about the Atlas operator. And he did this with his really cool accent and presentation. He said this: we can wrap existing schema management solutions into containers and run them on Kubernetes as jobs. But that is silly. His words, not mine. That is not how we work in Kubernetes. In Kubernetes, the way to deal with the stateful resource problem is the operator pattern. Is to have a specialized piece of software, a specialized CRD, a custom resource definition, and to teach your controller how to do all of these complex operations. Why is it good? First of all, for resilience. A reconciliation loop is like a retry policy with brains. It can decide what to do. Oh, this is a down migration. I'm going back in the future. Maybe I should deal with it in some intelligent way. Oh, this change is risky. I should break it down into 2 transactions because if I do it in one, it's a problem. So it's more resilient to have a process that can do progressive delivery and encode logic into the progress. Semantics. A CRD, a custom resource in Kubernetes, is an extension of the Kubernetes API. It means that it has a spec, something that you can use other tools to validate, something that you can consume with your standard Kubernetes stack, and it has a status that can be observed. Did this migration finish? So for example, our Argo CD integration knows how to listen to the status of the migration to know that if it can move to the next step. Flux CD automatically consumes the status field to know if the dependency is resolved and I can move to the application upgrade. Finally, operations. Operators are supposed to replace or extend human operators. These genius DBAs that actually know how to manage Postgres in production. And when you have an operator, you can codify all of these people's experience into a decision tree that your code will execute on your behalf. And now, for the risky part, a live demo. It's my hobby to do live demos. I recently presented in a big conference in Tel Aviv, in Israel, and my laptop melted and nothing worked, but I came out of it alive. Today I'm going to try again, so please focus your positive energy on the demo gods to help us succeed with this demo. Sorry? Ah, thank you, thank you. And we have, by the way, amazing Star Wars Lego as the prize. So if you stay to the end. Okay. Cool. So what do we have here? I have, can you see my screen? I have a Minikube cluster running. I'm going to install the Atlas Kubernetes operator. It's a simple, it's a simple Helm chart. While this is installing, we are going to provision some basic resources in our cluster. I am spinning up a MySQL container, a service that will expose it to the cluster, and the secret that contains the credential to the database. The secret is required for Atlas to work. Okay, let's make sure that everything is in order. I love this tool, K9s. You know it? It's for this CLI GUI for Kubernetes. So we have our operator is still coming up. Our MySQL is not up yet. It will take us a minute more. The Kubernetes operator chart installed a custom resource called an Atlas schema. We currently don't have any schemas in our cluster. And now we are going to apply such a resource on a database that is currently empty in order for us to be able to manage it. Okay, so I'm going to, still waiting for for MySQL, always the slow one. Yeah, ready for connections, good. So I'm opening a port forward so I can inspect it. And what I'm going to do is, in this terminal, I'm running a script that is doing a watch on the schema. So every second, it does a MySQL dump to show you how the schema is evolving as I'm doing the different operations. In this tab, I'm going to be applying my resource. You can look at my Atlas schema resource. It has a SQL attribute with the desired state, what I would like the database to look like. And I'm going to delete this briefly, just so you can see the schema evolve. So what we're going to do is to apply this manifest. And if everything works correctly,
oh, sorry, can you zoom out your competitor?
Can I what?
Zoom out.
Ah, okay. Okay, yes, it worked. So you may not have noticed it, but now what happened is I applied this Kubernetes manifest. I have an Atlas schema resource. I have the desired schema of the database. And the reconciliation loop ended, and now this is the schema of my database. Okay, so if, for example, I'm going to remove one column, I'm going to kubectl apply it, and you see immediately the schema is modified on the top. I think this deserves a round of applause to Atlas. Okay, now, thank you, you're very kind. So if you saw what just happened, you saw that I removed the column, and this column might have contained data, which is pretty scary, right? As an operator of a system, you don't want your developer to accidentally do something that's going to result in an unintended consequence. So for this reason, if you look in the top, you see that the Atlas CRD contains stuff like a policy. And I'm going to show you an example policy, which is a linting policy. So it will evaluate the change before it happened. And this specific policy will catch a destructive change, meaning a change that might lose data, before it happens. So for example, I'm going to now again delete the short bio column. And this time, you notice that nothing happened to the database. Now, if I will go back to my, if I will go back to my Atlas schema resource, Atlas schema, you will see that the state is ready false. So Atlas did not agree to move forward, and it's exposing the reason, the lint policy error. If I go to look at the actual manifest, you can see there is more details here, dropping non-virtual column short bio. So you have Atlas has brains. It's not just stupidly calculating the diff. It can evaluate the change against policies that you define. Okay, so this is one kind of policy. I want to show you another kind, which is a diff policy. The idea with diff policy is to be able to edit, to provide Kubernetes with instructions on how to edit the calculated plan. So for example, diff policy skip drop column. It means that if the resulting plan contains a drop column operation, it will just be omitted from the target plan. Okay? For example, another policy that we just merged today, if you are using Postgres, you maybe know that if you create an index and you do it concurrently, it can happen in the background. But if you don't do it concurrently, it can lock your table for writes. If the table is big, it's downtime. Okay? So you give Atlas these policies that are relevant to your specific setup so that the migration that it plans for you will be more accurate and reflecting the need of your production environment. Something very cool that is coming in the next few weeks is approval policy. So you can tell Atlas, if you detect a destructive change, it may be OK in my system, but it requires an approval step, in which case there is a way the migration is stopped, unless it was pre-approved ahead of time, and the operator can approve to the cluster to move forward in some UI, and the migration will move forward. Okay? So it's a way to control this complex operation of a critical resource with policy. You want to see this happen? Let's try. Okay, so again, we are still commented out on the short bio. We're going to apply it. Again, the column is not dropped. But this time, the schema is reconciled and the deployment will continue. So Atlas, the Atlas operator, lets you adopt the declarative approach, the GitOps approach. Your desired schema is described in Git, and the one responsible to reconcile it is the operator. But it will not do it in a stupid way that's going to risk your database. You can define the policy to make sure that you don't do damage to your production system. Atlas, the CLI, contains over 30 policies that you can apply. The Kubernetes operator is a little bit behind, but we are, as you saw today, we are constantly updating it with more functionality. So, to summarize, running migrations with an operator. Yay, it's the Kubernetes native way. Decouples migrations from your application. It becomes its own step. If you use it with Argo CD or with Flux CD, you can create a dependency between your application and your migration to make sure that the migration is finished before the application comes. We have safety features to prevent us from shooting ourselves in the foot. It exposes a clear migration status, a health check that you can consume by other tools to make decisions for your deployments. And in short, it's 100% GitOps automation for your database schema. Key takeaways. Kubernetes is a giant air conditioner. The Atlas operator is a Kubernetes native solution for database upgrades. We have dedicated resources. The database is not hiding as some file inside some container, inside some job. Okay? It's its own resource. It's open source. You can use classic version migrations or declarative migrations. In short, start treating your database like a piece of infrastructure. Thank you very much. I hope you found it interesting. I'll be hanging around here to talk about Atlas. In the end, we have a quiz with some awesome Atlas swag that we made especially for today. The Vietnam, we have one for Singapore for the rest of the week. We have a very cool Lego set. Thank you, Vincent, for hosting this. And have a good rest of your evening. Should I disconnect this, or do you need it?
Yeah. Is there anyone have any questions? Maybe.
Yeah, I have
Yes.
one question. So, I think it is two questions. The first one is I'd like to know, like, somebody go to the database and remove some of the column, and then Atlas can detect that, like the Terraform do.
Yep.
And the second one is because when we migrate the database, we change the schema, and also sometimes we change the record also. Let's say I have a table like the permission. We had the role admin, role developer sometimes.
Yeah.
So when we change the database, we want to update the schema and also add some record to the database.
Perfect.
So how can I ask Atlas to the process?
Okay. So great question. One of the advantages of running this in a reconciliation loop is that there is someone always awake to try to erase schema drift. So for your first question, yes, Atlas, especially in the declarative mode, will notice that a column is missing, and it will create it. In the declarative mode, we have something else that is called schema drift detection. So Atlas knows what the state is supposed to be, and it runs like a monitoring job. Every hour or every 6 hours, you get an alert, hey, somebody touched this schema. Second question was managing other resources, right? So like policy, roles, triggers, functions, all sorts of other. So we recently added support for triggers, stored procedures, functions, sequences. Roles permissions are coming soon. So in one of the next versions, all the security stuff, especially in Postgres, is going to come to Atlas. Atlas has an alternative DDL, like not use SQL, use something similar to Terraform, HCL, that is also very, very convenient to configure stuff if you don't want to use SQL. So I can give you more examples, but the short answer is it's a work in progress, and we're adding support for users and policy in the future. If you need to do data migration, to rewrite data, obviously the declarative approach is not going to work for you, which is why we still support the classic version approach. We offer lots of tools to help you to do this successfully, but it's not going to work with a pure declarative schema approach.
So basically, there are ORMs that user like into code. So like they have their own migration files as well. There is like migration folder with date, timestamp, and everything. So how like it will work with that? Because like that is totally like binary into your code. Like because you are using like let's say example Prisma, like Prisma or something like that.
Excellent question, and actually the lecture I gave last week is called Why You Should Stop Using Your ORM for Managing Migration, but you should not stop using your ORM. So Atlas has a concept called schema loader. So for each ORM, we have a plugin that can read the desired state from it. So I know to read from Django, I know to read from SQL Alchemy, I know to read from SQLite, from Ant, from GoRM. Prisma is actually, we got a request this week, and it will be out soon. But the idea is that Atlas can plan the migrations for you. It can do the declarative style schema apply. You point the Atlas to the Django directory, and it can do the same thing for you.
I just had a quick skip on your GitHub repository, and I noticed that in the policy session, there's just only support policy for the linking and div policy. So I would like to know, do we have anything to allow the user to define the custom policies on your plate?
So like OPA or something like that.
Yeah.
So we're considering that. We think that databases are a big problem, but not an infinitely big problem. So it's not like cloud infrastructure. It's a more defined set of issues because the amount of changes that are possible are pretty well defined. So currently, we have some freedom, for example, for naming. So you can give like a regex to say this is naming convention, so you can configure it. You can configure the severity of different checks. So this is a warning, this is a showstopper. And in terms of custom logic, we are still on the fence. We're not decided yet, but it's a community project. And if you join us and discuss and present a use case that is really compelling, cool. Yes?
Atlas provides some backup management or interface or something like that. For example, I have a database on it's MySQL on the cloud providers, and when I want to when I run the migration, I want to back up my database first and attack to and link this backup to this operation, and when the migration failed, I can run back to this latest backup.
Yeah, okay. Vincent, you didn't tell me the crowd would be so intelligent with like really great, so excellent question. And what you are talking about is basically snapshot-based testing. So one of the powers of Atlas is it's a CI solution. It can evaluate your changes during CI. We looked at Atlas today as a runtime tool, deployment, CD. But it's also a CI tool, which means we have a GitHub action, integration for GitLab. So we can detect a lot of stuff even before you merge your code. The lint policy in production is like a last resort. It's the final showstopper. But this stuff should be detected during code review, and not by a human, by a linter. This is why it's called Atlas Lint. So the policy of verifying a change on a snapshot, basically saying, I want to know how much time this data migration is going to take before I try it on my production database, or I want to simulate it on real data. A common strategy that we heard from our customer is, I will take a RDS snapshot, spin it up, run the migration on it, make some predicate, some assertion on the target result, that the data looks okay, that the time the operation took, that the CPU was something like that, and only then approve it for, this is what you're talking about, right? So the short answer is it's not supported currently, but it's definitely on our roadmap for the enterprise product. I don't know if it will be for free. It's a very commercial use case for a company that is, cares about the data. The database is big enough to be worried about this kind of stuff. But it's definitely a problem that is very interesting, and we are looking to solve it. I think, yeah.
We need to move to the next talk. Thank you so much for
And yeah, come talk to me. Thank you.
And you said